I want to thank Matt and Matthias for setting this up and getting this going. You guys showed great leadership. You know, a lot of kudos to really what you've done. This is excellent, and I know from the FAA standpoint, I really appreciate this. And so, without further ado, today's panel, basically, this afternoon's panel is weather reporting in the NAS, basically current and future needs. We have 3 different panels. I don't know if we can scroll a little bit. All I'm seeing is the top part there, Matt. Yeah, if you go to the first, go to the second slide then. Sorry, there we go. Perfect. All right, so panel 1, we'll start off with the present state of the observations. We'll talk about the lack of observations, and then we're going to hear from a few of our keynote speakers here. Tom George from AOPA in Alaska. He's going to discuss the general aviation needs. There's a lot of focus here on Alaska, but you'll start to see the trend of why we're doing it up there. Don Ike from the NTSB will talk about the accidents in low-level and remote areas. Then we've got David Kochevar from the Alaska Aviation Weather Unit, who will also give us his perspective on challenges operating in Alaska, lack of the weather reporting, and what they're faced with. Panel 2, we'll have a short break in between panels here, but panel 2 will be, I guess, myself discussing the new VWAS standard, and Walter Combs can't join us today. It's Walter's big piece of this, and I'll discuss it when we get to that point. But he's tied up in a joint JRC meeting today. That's where he gets his money and his support, so he has to be there. After that, Danny Sims will present on where we're at with RTMA and the evaluation of RTMA. Do a short break, and then panel 3 will kick it off with Kevin Johnston and John Steventon, 400, Kevin and ANG C6, talking about the proposed FAA weather research that we have for UAS operations. And then we're going to get the industry's perspective on that. What has the industry done? Where are they going? What are some options that are out there? So Don Birchoff from True Weather, Chris Bauer from Hughes Aerospace, and then Justin Hilliard from UPS Flight Forward, which was the first 135 beyond visual line of sight package carrier, and Justin will be able to cover, what UPS is doing, where their challenges are, and we're hopeful that panel 3 will be able to evolve into maybe even the fall presentation or the fall FPAW, and continue to help us bridge the gap for lack of weather reporting in the NAS. Without further ado, the next slide, I'm going to turn this over to Scott Stacy, who works with me in AFS 200 also, and Scott will discuss the NAS weather reporting.
Thank you, Gordy. Everybody hear me okay, I hope? But yes. Right, looking at in the NAS, what's missing, where are the gaps, and here's some data, some information that will help lead us into the rest of the day. So currently, for certified weather reporting systems in the CONUS, we'll stick in the CONUS right now, there are 2,278 AWAS or ASOS units. And that covers an area of approximately 178,000, almost 179,000 square miles. That leaves in CONUS 3,041,149 square miles that does not have any AWAS or ASOS or certified weather reporting of any kind, which means 97.5% of CONUS does not have any approved source of weather. In Alaska, the numbers are about the same. It's about 98% that does not have it up there. And we're going to be focusing pretty much in this portion in the boundary layer areas. So upper air data is a different area, but let's focus basically on the lower altitude areas. Next slide, please. So here's a picture of Alaska. And if you're not familiar with Alaska, from east to west, it goes basically, just to give you an idea, 20% of the U.S. landmass. And it goes from basically Jacksonville all the way over as far left on there to San Diego. It goes from about Dallas up to Minneapolis. Over on the right-hand side, if you zoom in, all those little dots are actual ASOSs or AWOSs. So you can see vast areas of no weather, any kind of certified weather or observation or anything else that's needed at a lot of the airports. Next slide, please. And we look at Alabama, you can see those are also all the AWOS and ASOSs. And if you zoom in over on the right-hand side, if you look at that, again, you can see just even in CONUS area, in Alabama, there is just really a whole massive area of uncertified weather. So when we're talking about boundary layer, which is extremely critical for information, this is problematic. Next slide, please. So when we don't have weather in those areas, we have a lack of METARs. Obviously, what that does is it creates voids and massive gaps for forecasting, or again, going back to the observations. So what does it impact is widespread operational impacts. Economic impacts are directly attributable to weather, and the accident facilities are, fatalities are absolutely a part of this also, and Don Ike will talk about that later. So we need to get those areas covered for any kind of operations that deal with something along the lines of any UAS operations that are operating in this boundary layers, any of the emergency helicopter operations, and any low-level GA traffic, which is the uncontrolled airports that have no weather reporting, and also Part 137 agricultural operations. So this is in the farming areas and the likes. So we need data, and the only way to get that data is to look at other options. Next slide, please. So currently, the gold standard, our METARs, are being driven from AWOS and ASOSs, and it is in the FAA our only approved source. It's only used for IFR operations. We don't have alternate sources for IFR operations. It is FAA only approved sensors that are allowed on these systems. The FAA only allows technicians to certify and to repair these AWOSs and ASOSs. The new technologies that are out there have been smothered by FAA constraints that are in place, and industry has been very reluctant to come up with their own other solutions to add to that because of fear of potentially the FAA not approving it. So AWOS and ASOS cost are approximately $1.2 million per copy. So just like in Alaska, if you have 100 airports that need some sort of information in terms of weather, certified weather, that's problematic in terms of the cost factor. So under the new Airports Improvement Plan funding, it does allow for procurement of these weather systems. So there's really nothing right now that's on the horizon for any other viable solutions to look at this, or is there? Next slide, please. So industry has been exacerbated, and particularly up in Alaska areas, they were dealing with numerous weather issues, and they've been asking for some help up there, and they were not able to get a whole lot of movement from the FAA just through the constraints that we have that are built into place. So industry went and sought congressional intercession, and Gordy was intimately involved with this. So Gordy, if you want to take it over from here for this slide.
Sure, no problem. So a number of changes were made to public law, either through funding bills or through the FAA Reauthorization Act. One of the key changes was, like Scott was alluding to in the other slide, AIP funding used to it previously did not allow for procurement of weather systems. Now it does. However, that's not really the solution at $1.2 million per copy to really do this, and AIP funding's, generally for airport improvements. So, in remote areas, that's probably not going to be the answer either. But it does open up a funding stream, to expand the ASOS and AWOS. In Alaska, we had two bills that were done over different periods of time. House Joint Bill 31, Section 119 F allows 121 carriers to operate terminal VFR into airports without a METAR or TAF, as long as they have approved procedures. Currently, 3 operators in the state of Alaska have that. This is, by the way, in a non-contiguous state. It does not allow for that in the lower 48. And then HR 302, Section 322, kind of jumped over that a little bit. It allows 135 carriers to conduct an IFR instrument approach without destination METAR if it's supplemented by non-certified observations such as weather cameras and has approved procedures. So the language is similar between the two, but the 135 allows them to conduct an instrument approach without a destination METAR. And I just want to say right up front that the FAA is not happy with this. Okay, we don't think there's any sort of equivalent level of safety of operating into a terminal without weather. We do agree, and we have put into some pretty good mitigating factors, especially on the 121 side, and we've established some pretty high minimums for those operators. But it still allows them to conduct operations into smaller, I dare use the term airport, let's say location in the state of Alaska, whether it's a nice runway or something where they're going to bring freight in or something like that. So that's what happened with the public law. So that does give the FAA the ability to look at other options. Next slide, please. Scott, I think this is yours. Yep.
So what are the potential solutions? So we need an alternate. So maybe we'll call this our silver standard. So one of those potential alternates that we have been looking at is called VWAS, or the Visual Weather Observation System. And this is what has been going on up in Alaska for quite some time, is having weather cameras, FAA certified weather cameras that are really, from what the data that we got, CFIT accidents were reduced 70% when these cameras were starting to be installed, and all they are is visual. Now, what if we took that and enhanced this this system? And that's what's currently being done right now and being experimented with. We'll talk about it a little bit later. One of those upgrades is an actual 360-degree camera that will pan, tilt, and zoom, so anybody can look at anywhere in that area and get an idea of what the actual weather looks like, in addition with potentially a METAR that comes out of this in the future. So that's being experimented with right now, currently up in Anchorage. And it will have additional sensors that will hopefully give us a ceiling and all the information that's needed for the METAR. What about industry? Now, with the VWAS system specifications, which would be open sourced, this will allow the industry to go build a cheaper mousetrap. They'll come up with cheaper solutions. So individuals can, here's the data, here's the standard, now go forth and build your own, and then go from there. With more of these systems that we will receive, obviously, more data, and obviously the more data that we have, the better it will be in order to help provide forecast models. One of those areas is called RTMA, which is real-time mesoscale analysis, and that's going to be discussed a little bit. John, you want to latch onto that a little bit on the RTMA?
Sure, if you can go on to the next slide there. Within 400, we have a small research budget for specific to weather wedge. And one of the projects that we fund is the project through NCEP and EMC, which is RTMA. Our first year's analysis provided some real positive results where we did the study in lieu of an ASOS and an AWOS system. and compared those to those systems. And our next year statement of work is going to be finalized to focus more into the regional areas. So without getting into greater detail to RTMA, which will be covered by Danny Sims, I'll save that for the next panel session. We do have funding provided, like I said, for the next phase of RTMA. And we're also looking at funding to be arranged for specific projects with VWAS development at some airports up in Alaska. That's about it. That's all I have. I'll pass it back over to you, Gordy.
Mute, Gordy.
I'm unmuted. There we go.
There you
Sorry
go.
about
There you go.
that's it for the slides, right, Matt? There's no more slides in this slide deck.
That's correct.
Okay. So, normally right now we take questions, but if any questions with RTMA or VWAS, we're going to discuss that in panel 2. So maybe we can hold on to those questions. I don't know where we stand with questions. If there are other questions, we could probably take them now, or we can just continue on.
So if we can just take a minute here, Gordy, to remind our 100+ participants still hanging with us that there is a chat function in Microsoft Teams. It has the little kind of dialogue boxy looking icon in the dashboard. We've had a couple of questions already, one of which was answered on the fly by Tom Ryan, thank you, regarding the phrase 1.2 million per copy. Does that mean per unit, per individual AWOS ASOS unit? And Tom answered yes, so thank you there. We also have a question from Rocky Stone in the queue right now that has to do with VWAS, and per your guidance, Gordy, I think we'll try to hold off on that until we get to that section of the conversation.
Sure, that's fine. Okay.
And if you'll send in your questions along the way, we'll queue them up and then answer them in order when we get to the end.
Thanks, David. Okay, so I think we're going to move on now. We'll move on to Tom George. Tom George is with airline AOPA folks, not airline, Aircraft Owners and Pilots Association in Alaska. Tom has been a great proponent for safety. Tom and Rundu, can't thank you guys enough for all you do for aviation. Real big proponent to expand weather reporting. So Tom, are you able to unmute and present?
I'm unmuted. Are you copying me okay?
Sound great.
Okay. So again, good morning or afternoon, depending on your time zone. Again, I'm Tom George. I serve as the Alaska Regional Manager for the Aircraft Owners and Pilots Association. And I was asked to talk again about operating with a lack of weather reporting. And I will burn through this quickly since there's a little bit of overlap. If we can have the next slide, please. So we've already talked about numbers of weather coverage, and I just wanted to very visually kind of scan across the country, looking at the density against a flight chart. Then the southeast, next slide, please. Fairly similar density in the Midwest, next slide. By the time we get to the Pacific Northwest, it thins out a bit with coverage along transportation corridors and, of course, a fair amount on the coast. So even though I'm going to focus on Alaska today, the needs, as we've already heard, are in many parts of the country. Next slide, please. So jumping to interior Alaska, this is a look at the center of the state, and a lot of these stations are about 100 nautical miles apart. In the interior. So yeah, the density has changed a lot. So we're challenged to figure out how to operate. And if we can go to the next slide, and this is an example of a route. I fly a Cessna 185 from Fairbanks in the lower right here up to Barrow, or Itkiavik, as it's now known as. That's a 400 plus nautical mile 4-hour flight, and I've got one station in the middle of the in the Brooks Range, the major mountain range I have to cross, one station on the south side, and the real question often is, gee, do coastal conditions, are they confined to the coast, or do they make it into the Brooks Range? So yeah, this is kind of the operational impact on how we how we have to function, just given the density of AWOS and ASOS stations we have today. Next slide, please. And again, in contrast, here's a comparable route from Chattanooga, Tennessee to Orlando, Florida, and I think I counted about a dozen weather observations just immediately along the flight path there. Next slide. Jumping back to the interior of Alaska, again, the slide we just looked at, now the question is, so where do people fly in terms of our need for weather? So given this orientation or kind of representation of the northern part of the state, let's go to the next slide. And these are combination of radar and ADS-B tracks of aircraft. This is data from last July. It's a week's worth of flight tracks, only surface to 10,000 feet. So again, we're staying at the low level of the atmosphere here. And as you can tell, aircraft are not just going from point to point to those different communities, which is essentially where the weather reporting stations are. They're all over the place. Up on the north coast and out to the west, you can see what I believe are probably marine mammal flight tracks on a transect there. And in fact, if you even look at little swirls where they swung around to look at something, you can probably come up with the location of the whales from this track data. So there's just a look at where where some traffic, flight traffic goes. It's a lot more than point to point. And so, yes, we need a whole bunch more weather to be able to do this safely and reasonably. Next slide, please. And as we've talked about, again, in terms of need, NTSB had a roundtable in Alaska last fall. And, you know, one of the things that came out is that we have 2.3 times as many accidents as pilots in the CONUS do. Unfortunately, a fair number of those are fatal. There's a web story link there retrospectively if anybody's interested in the detail. So the question is, what do we rely on to get around today? Obviously, the existing AWOS, ASOS stations that we've seen, weather cameras, which I'll talk about in a little more detail. We rely heavily on PIREPs to fill those gaps, and we even use some experimental products. So next slide, please. The FAA weather cameras, and I understand Walter Combs is not with us today, so I don't know if we'll be talking more about the cameras or not. This is this network of, I think it's some over 230 cameras across the state that have anywhere from 2 to 4 camera views per station in different directions that give us a look updated every 10 minutes on what conditions look like in those directions. A very important feature for weather purposes is that we can do a video loop, look at the last 6 hours to get some trending information. Where those stations are co-located with AWOSs and ASOSs is incredibly important to us, because now the AWOS will tell us it's a 6,000 foot broken ceiling. A look at the camera tells you whether it's a nasty, ugly 6,000 foot broken layer that with big threatening clouds, or whether it's a pretty thin layer that the sunshine is streaming through. And that information may be hard to put into words, but it's very valuable as a pilot when you're contemplating whether you want to fly to or through that area. In many cases where we don't have weather stations, these are the only information we have. And again, they're incredibly useful in that regard. Next slide, please. We're also using some experimental products, and Dave Kosovar may talk about this a little bit later, but Alaska, in addition, I guess I didn't mention, we've got about 136 AWOSs in the state. Only 39 of those locations give us terminal area forecasts to be able to predict the future about what conditions we might anticipate as we're flying there. Through this experimental Alaska aviation guidance, now we can get a TAF-like product that looks at least 6 hours in the future and gives us some basis to to anticipate what the weather is liable to be on a more localized area. And again, this is an experimental project going on for a year, and we're hopeful that if this and the silver standard that we heard about earlier comes about, that we might see an expansion of that type of thing. Next slide. In terms of user feedback, AOPA conducts weather surveys, and actually pretty much annually for a number of years now. When I looked back to the 2017 weather survey, where we asked pilots what information did they most want in terms of weather products and services, and then we forced them to, the first question, let them tell us anything they wanted. Then we said, of those, which is most important to you? More surface observations came absolutely to the top of the heap of things that they wanted to see in order to be able to operate better. In the 2018 survey, again, we sometimes break out Alaska pilots versus CONUS pilots. To the question of how often did you use unsolicited PIREPs, the Alaska pilots tend to contribute more than CONUS pilots, which I think is, again, an indication that we understand that those are our gap fillers to help understand what conditions are between those 100 nautical mile spaced surface observations. Next slide. Finally, we have a current weather survey underway right now, and one of the questions we're asking there is, if an uncertified weather observation was available at an airport you fly to that doesn't have an AWOS or ASOS, would you use it? And the answer is overwhelmingly yes. Yesterday when I checked, we'd had like 2,500 people engage in this survey already. And again, it's ongoing, so we'll get a report out when this gets summarized. Another question asks, what elements of a weather report are important to you? Ceiling, visibility, and wind definitely rise to the top of the list of what are the things that we most want to see in an uncertified weather station. Next slide. So reflecting back a little bit, back in 2017, we and a bunch of other industry groups sent a letter to the FAA asking for more surface observations, both to distribute some of the certified less than AWOS 3 observations that currently aren't in WMSCR, but we know that data is out there, and calling for an uncertified system of the VFR standard. So we are very pleased, obviously, with what we've just heard in this meeting, along with the weather camera program, and we're looking forward to developments of that. We are ready to support developments of a CONOP. Somebody's got a mic open. And plans for data distribution. So we think there are a lot of details here to work on in addition to the equipment to make sure that we're getting the information we need and figuring the best way to distribute that information to the aviation community. We're also very willing to help find people to test the prototype weather that'll be rolled out this summer and provide feedback on it. Next slide. And that's all I wanted to cover. I appreciate being here and look forward as we kind of carve new ground in this important area. Thank you very much.
Do we have any questions for Tom?
We've got some questions and several questions that came in for the panel here. Do you want to go ahead and just run through them here? I'll tell you what they are if you're ready. Okay. There was actually a couple of questions on VWAS, and one's from Rocky Stone, and let me get back to it. Does it include a pressure sensor? And let me go ahead and give a second question on VWAS because you might answer them at the same time. Is there any, this is from Scott Sampson, is there any information on the timing of the VWAS specifications? Will such systems be permitted to receive AIP funding?
So on the pressure sensor, the answer is yes. It will have a pressure sensor. We'll have all the sensors that an AWOS has. That is the goal. There is a prototype running at Hood Lake. There will be a system. Well, I can get to that in the VWAS presentation. And from Scott's standpoint, first we have to prove the system. So as far as AIP funding, that's a big question mark. We do have potential to get some additional funding for this with some support from the folks up in Alaska, and that we're kind of hopeful that'll come through in a funding bill. So that's TBD, and we'll talk more about that in the VWAS presentation. Any other questions?
There was a question from a mystery guest. Oh, it looks like Rex. I'm sorry. What is the estimated cost of the new 360-degree weather camera being tested in Alaska?
The camera itself, I'm not exactly sure. We'll have to take an IOU for that. I think Walter may join us a little bit later. If he does, he will be able to give you that number. But I've got some information on the timing and rollout of those cameras in the presentation too.
And I'm sure that mystery guest is almost certainly Rex Alexander, and mysterious does fit Rex well.
Hey, Gordy, would you like to answer the question in terms of the total cost of the system, what it is today?
The VWAS?
Yes.
The VWAS is gonna come in about $100 to $120,000 per site, so it's 10 times cheaper than an AWAS.
Okay,
but if you're just a question on the camera, Rex, I don't know, but there is a camera currently in place at Palmer, and we do have a demo of that planned for panel 2.
and we have 2 other questions is all remaining if we've got time for that, Scott. One is where to go? Oh yeah, first panel. This is from Mark Faniff. Didn't hear anything about airborne observations. Any work to expand in that area, or was it meant to only cover? See more surface observations.
Well, thanks, Mark. And that question, the short answer is yes. This is looking at the surface observations. However, panel 3, we're hoping to expand our reach here and look at what industry options potentially there are to kind of fill the gaps. And that certainly would be something that we're going to want to look at. And that's when Kevin and John will be leading that group.
All right, and one last one from let's see, Mr. Garcia. Let's see. It says, what is the use of polar orbiter satellite products for aviation in Alaska? Are there any products such as polar winds, etc.? Moreover, UMETSAT will launch additional satellites that will increase polar coverage on top of what the NOAA JPIS is already doing. Are those planned? And those are planned for launch in 2023 to 2024. So I think the question was initially the polar satellites for Alaska. What was the planned use for those?
Yeah, I can't answer that. I would have to defer to the Weather Service folks that are attending. I don't know, Kevin Stone, are you able to answer that, or I think Kevin's on, but I'm not sure. Maybe take it for you.
This is Tom George. I can answer that partially. Yes, there are some projects using JPSS satellite data, specifically an experimental product that's out right now that looks at cross sections and gives cloud heights and cloud phase on a test basis on 4 or 5 different routes in Alaska. And there's some other products that are under development in an experimental fashion. So yes, that is being looked at least with that one satellite. I don't have information on the other satellites that were mentioned.
Okay, just one final follow-up question on the VWAS from Rocky Stone. Since VWAS is an order of magnitude cheaper than AWAS, are we sacrificing anything? Is there as robust as fault detection for things like erroneous readings?
Yeah, actually, it's probably a little bit more robust because with the newer technology, it does a lot of self-validation that is not resident in the current AWAS ASOS system. So the cost savings is it won't fall under the same certification standard. It will be designed to a standard. It will have self-validation and alerting capability, and I'll talk a little bit about that when we get into the VWAS. So that's the huge cost savings to this, and we're really hopeful that, you know, establishing this VFR weather standard will allow us to bridge the gap. This will not replace the AWAS, but it actually kind of leaps over it in a lot of regard because of the ability to bring the VWAS information and the weather camera information in a 360-degree pan, tilt, and zoom capability into one product, and it allows us to have a lot more value added than the current system has. So we're hopeful that this will do what we think it will do, and this summer I'll kind of roll out what we're planning to do to do the validation of the system, and it will be a side-by-side validation. So we're hopeful, and we're hopeful that, you know, once we prove the system, it will expand beyond Alaska. But Alaska is our test bed. Alaska, through legislation, gives us the ability to say yes, it's good enough to operate. We need to do something, obviously, because you know, we've struggled for so long in the state of Alaska. Now's the time, and the technology's there to kind of bridge the gap. So that's why we're pushing for the VWAS.
Great, thank you, Gordy.
Yep.
All right, that's all the questions that I had for now. So I'll turn it back over to the panel, or Matt.
I don't know, Matt. You want me to turn it? Keep going here.
Let me find my mute button. Absolutely, your deal. I'm just a slide flipper at this point.
All right. So without further ado, I guess we'll go on with Don Ike from the National Transportation Safety Board. Don's been a great proponent of weather. He's a meteorologist. He's got you know, got a great resume. Working for the airlines for many years, and has been with the Weather Service for. Well, Don, you can kind of tell us how long it's been, but he's been a great resource for all of us when we had questions on really what's the impact. And so, Don, I don't think you have any slides, but you do have some data that you'd like to share. So, Don Ike from the National Transportation Safety Board.
Well, thank you, Gordy. Basically, I've been working aviation weather for about 40 years with about over 25 years now with the NTSB. We don't keep per se stats on remote locations or how far away the closest weather reporting station was, but we do see the issue, and as we see accidents, we will point them out. Alaska definitely is a beast of its own with a high percentage of accidents. Just even when you start looking at Part 135, air taxi, cargo flights, a higher percentage of those accidents are occurring in Alaska. It has gotten our attention in the last few years. And just as a quick review of some of the cases I was looking at this morning, just in a 10-year period from 2008 to 2018, there were over 200 Part 135 accidents in Alaska, with the majority of the fatal events being weather-related, VFR and IMC conditions, turbulence, but weather is the biggest factor in Part 135 accidents in Alaska, providing the cargo, passengers between some of these remote villages. So it is an issue, and again, we do use weather cameras when we're doing our investigations. We do see some great benefit in the cameras, but cameras don't tell you all. We like what we're seeing with the cameras, but again, we could provide more data. I have seen multiple cases where the weather cameras have reported worse conditions than are being reported by the AWAS or ASOS sites that are augmented, in the fact that has gotten us concerned that is the augmenter doing his job? And these have been fatal accidents. Some of the other factors, of course, in Alaska, most of the operations are VFR. So again, VFR and IMC is a big factor in Alaska. Mountain obscuration, controlled flight into terrain, all weather-related events again. But we do also see those in the lower continental United States, especially out over the west, the Pacific Northwest. And even if you want to look at like the Kobe Bryant case, even cases in Southern California where you have a lot of reporting stations in the valleys or at the airports, there's not a lot of cameras or weather reporting in passes that operators can use. So we have been pushing increased weather camera use in the lower 48, especially in passes where VFR and IMC is a big concern. We've also supported cameras expanding in Alaska as well as in Hawaii, where we've also seen some recent 135 accidents where we've gone VFR and IMC conditions. So weather reporting is, again, critical. We need that data. And again, we recommend better and more quality use of the equipment. We're on the test phase. As new tools get available and we see them in operations, we'll make our comments. But again, having observations is critical. There are only a few cases that we don't have close weather reporting events, but again, everything is critical when we document. In the lower 48, we've got the luxury of using radar, satellite coverage, but again, in Alaska, satellite is very hard to tell and use on an operational level. Radar coverage is not there, but again, they don't get the severe storms as often as we do in the lower 48. But again, low ceilings, visibility, mountain obscuration are key factors up there. That's all basically I have. I haven't provided any stats or anything because, again, this is a big subject, but I'm open for any questions if anyone has them.
Any questions for Don?
Let's see. We do have a couple here. It looks like Matthias actually sent one in. Let me see. That was does the weather camera program provide an archive of images or feed for just real time? So is that? I'm sorry. Was that for Don Matthias or?
No, it was just a general question about the weather camera program that I wanted to put in the hopper for clarification.
Okay.
They do have an archive.
Yeah,
I've been able to get that. Don probably, yeah, go ahead.
Yeah, we'll use the archive. Again, it's limited to how many days, but it is available for accident investigation use. We'll go back and reconstruct it from the FAA, and Walter Combs has been our big aid in that area too.
Thank you. Any more questions for Don?
Just one comment, Don. You made the comment about Kobe Bryant, and I completely agree with you that that case there does cry for additional weather information, for better aeronautical decision making. He probably shouldn't have been into that valley, when he made that turn into that valley. So we're hopeful that people will start to see the light here with what we're trying to do with this VWAS standard. And then we're hopeful that will translate into better modeling data, as Scott said in his opening brief there. So, nothing else for Don. I think we're going to move on then. David Kochevar from the National Weather Service in Alaska. David, are you up? Okay.
David, have you ingested helium?
Yeah.
Uh-oh.
Uh-oh, right. we got some sort of issue here with your microphone. You sound like a Mickey Mouse or Minnie Mouse.
One of the chipmunks.
One of the chipmunks, yeah.
Slow down the turntable.
David, maybe you could mute and then call in. Do you have the number? There was another.
Yeah,
question,
there's one of the. Yeah, you want? I'm sorry. Go ahead, Gordy. You want to catch that question there?
Okay. This is from I guess Scott at Say Weather. Interest or need for existing non-AWAS but NSIT calibrated automated weather systems. Certainly that's a potential. One of the things that when I get into the VWAS here is I will tell you that basically we're taking the VWAS and we're attempting to base that standard and then write a spec. So there will be a spec for what you need to be. And Walter gives it like, if you're this high, you gotta be this tall to ride the ride. And if you have, if you meet that standard, then we will host the weather information on the weather cam site. So that'll become an approved weather source for VFR operations. So that's the thought process we're going to. We don't believe that the FAA will, or the U.S. government will fund thousands of these VWASs. However, in the state of Alaska, we're hopeful we can get enough to bridge the gap until we can get to that point, develop that standard, and then get industry buy-in, and then also discuss other options. And we'll get into that a little bit in panel 3 about what is good enough for UAS operations. Right now, we benchmark everything against the AWAS standard. So the AWAS tolerance, the RTMA is being looked at that, and the VWAS will be looked at that. So we're going to measure them up as how well it performs. So I see David's dialed in on his new phone, and David can.
If you'll unmute yourself, David, if possible, I've got your slides teed up.
All right, great. Do I sound less like a chipmunk now?
Oh man, you are the basest chipmunk I've ever heard.
Alvin, yeah, I don't know what happened. My apologies, but thanks for being patient and to fill that time for me, Gordy. So thank you for the invitation to speak on this panel. Gordy asked me to kind of speak on some of the challenges that we see with forecast operations in Alaska, and really, you know, it's a pretty broad topic, and so just in the interest of time, I'm really just going to focus on how the limited observational network that we have, since that's kind of the topic of this panel, you know, really limits us from a forecast operations perspective, and then, you know, challenges moving forward and monetizing our aviation services. So next slide, please. So to start out with, I just wanted to briefly go over what we have as far as forecast offices in the state of Alaska. So we have our cadre of 3 forecast offices that do our tasks, that have aviation responsibility, as well as a number of other responsibilities as well. Center Weather Service Unit here in Anchorage, as well as the Alaska Aviation Weather Unit that Gordy mentioned, which is our unique MetWatch office that just services the state of Alaska. Next slide. So the AWA is really does the lion's share of the aviation services for the state of Alaska. So the graphics that you see there, which are a little bit different than what you might see from AWC in the lower 48, but they're also doing the AirMets, the SIGMETs, and working with our both internal and external partners to both get the message out, take feedback on the products, but internally, really a lot of what they're doing is ensuring that our forecast is consistent and trying to improve what we call our collaborative forecast process. And the one really critical piece of that we're moving towards is that moving to more of a gridded forecast environment or a digital forecast environment is going to be absolutely critical to improving that collaborative forecast process. Next slide. So as I mentioned, the three forecast offices that we have, the one thing I did want to point out here is the map on the bottom right, where you can see the huge areas that they cover, as that's superimposed over the lower 48. The Anchorage office in particular has the most TAFs of any forecast office in the nation, with 17. Fairbanks, I believe, is third in the nation as far as the amount of TAFs. So, you know, in addition to the other services they provide there, the aviation services that they have are far and beyond what you see from a lower 48 forecast office.
It's a good thing, David. This is Matt Franzak. It's a good thing your forecasts are easy, so they can do that number of forecasts.
Yeah, exactly. No weather and a lot of observations to help out with that. So, yeah, certainly a big limitation for that. Next slide. And the last but not least, our Anchorage Center Weather Service Unit, co-located with the FAA Air Traffic Control Center, that's providing the on-site support and the focused products for the FAA. And next slide. So I wanted to start out by comparing, this is kind of similar to what Tom showed a little bit earlier, but this is a map of all of the different observations that we have I chose the upper Midwest just because it's where I'm from. But so on this map here, the color-coded larger circles you see are any observation reporting a flight category, so reporting ceiling and visibility. And then the smaller gray circles are essentially every other network. So these would be networks that aren't providing ceiling and visibility, but mostly providing things like temperature and wind and relative humidity and things like that. So as you can see, a very, very dense coverage, especially as you get east of the Dakotas. But as we compare to Alaska on the next slide, you can see it's quite a bit different. And I wanted to show this kind of all at once to show not only the limited, certified aviation observations that, we've seen a couple of times already this morning displayed in Alaska, but just wanted to point out the overall observational network and how coarse it is. When you're looking at every single network and just the limited data, some of the smaller dots there that you see there might just reporting something like temperature and maybe a rain gauge. So not even totally useful from an aviation perspective without something like wind. And if you think back to Tom George's presentation that showed where most folks are flying under 10,000 feet, you can see a lot of those en route areas are really not covered by any type of observation in Alaska. And I don't show the webcam network on this one, but the network would be fairly similar to what you're seeing for these other types of observations. Next slide. And so last but not least, one of the problems that we see, and this was just a snapshot that I took earlier this week, not necessarily a good day or not necessarily a bad day. This wasn't, really necessarily related to COVID or any issues with maintenance for that. But as you can see, the gray triangles on here are 12 AWOS sites that weren't reporting that day. So 12 of the 157 sites total we have in the state. Due to maybe a communications issue or a maintenance issue or a equipment issue, just were not reporting entirely that day. So a little less than 10%, but when you have as coarse of an observational network as we do, it's certainly a large impact, not only to our forecast operations, but to the aviation community in general. Next slide. Can you go to the next one? Looks like that might have gotten out of order there. No? Okay. There wasn't. Oh, okay. Unfortunately, it looks like. So there was supposed to be a slide in between that did have the 5 and the 10-hour forecast. So I'll try to point out the best that I can here. The most critical part is unfortunately hidden by the graphic there. But one of the big impacts that we see when it comes to the limited observational network and the, let's say, the quality of gridded forecasts is we have an experiment going on right now with gridded lamps. So this is a gridded forecast product from MDL that is an intended expansion on the text products that we've been using in our aviation services for quite some time now. On the 0-hour analysis, there was 3 very large areas that I was hoping to point out that you could see there were some very large corrections made based off a few observations that were quite a bit different than the background forecast field, to where one observation made changes to the forecast over hundreds of miles. And this is a big limitation that we see in our gridded forecast quality, and especially when it comes to things like ceiling and visibility, that they're very, very limited when it comes to forecast quality. You can kind of see this on the 5-hour forecast. If you look in kind of northeast Alaska, there's an area of kind of reds and oranges. Yeah, right under your mouse there. So that was an area for Yukon is what caused that huge area. So a localized observation within a valley that caused a pretty broad area of low IFR conditions that likely were not meteorological or representative of what we actually saw in the observation. But because of the weighting of a gridded forecast product like this, especially early on in the forecast period, it supplied a pretty major correction. You can see then on the 10-hour forecast that isn't quite as apparent from that same area there. So we do see some improvements from this as we get into later on in the forecast periods, but in that 0 to 6 hour period that's so critical for aviation is where we see this the most often, which is definitely a concern when we're looking at forecast quality. Next slide. I also wanted to touch on an experiment that Tom briefly mentioned as well, but the Alaska Aviation Guidance experiment that we started last spring, that really started from an FAA request over 5 years ago now to produce these TAF-like forecasts or aviation guidance at airports that are not serviced from a TAF, to try to fill this need and focus on smaller operators and VFR operations and supplying these go, no go type decisions. So we're doing an ongoing experiment and taking feedback at the moment with this, totally automated piece of guidance that we're not able to make any changes to as weather service forecasters. The initial request was for 157 sites, but we are only testing 61 of those for now, because there really aren't a lot of sites remaining that have an observation currently at that airport. And that's the way this LAMP guidance is currently operating is an absolutely critical piece. It's something that they're working on, but that, I'll go on the next slide as far as, we'll have to, after this experiment, determine how we're potentially going to expand this to future areas, because the need for this type of guidance is far and beyond anything that we could supply from an observational perspective. And next slide, please. So kind of putting it all together, I wanted to mention how this limited observation network is really causing us a challenge when it comes to moving forward and evolving our aviation services. So there's three pretty major projects that I have listed there in DAS and Digital Aviation Services, GFA and AvMet, that really, we absolutely have to be into a digital gridded world to get there. but to get there, we really need to have forecast guidance that can be implemented without much forecaster discretion. That's one of the major changes when it comes to transitioning from a text-based operational forecast to a gridded-based one is the time needed for grid editing to make major changes is potentially much higher than making simple changes to a text-based product that can be done relatively quickly. And also, just as far as moving these projects forward, there's always challenges with doing verification of new model data, new data sets with the limited observational network that we have. With the current stance with the webcam program, it's helpful, but it's difficult to do, especially a long-term verification using that kind of data set, because it's very much more of a subjective versus objective verification that you're trying to do. And this is all very much tied into RTMA and IRMA that'll be discussed a little bit later on, where we have noticed because the background field for a product like RTMA is a gridded model forecast. I wish I could have shown you the example from the gridded lamp at the 0-hour analysis, because it was a really good example of some of the poor data quality that we see in those analysis type products when it comes to these aviation elements, in particular ceiling and visibility.
Hey, David.
And trying.
David, I'm sorry, this is Matt. If you want to send me in PowerPoint format that single slide, I'll be happy to throw it up here for you.
Okay, let me see if.
Well, you have to keep talking while you're typing, which means you're multitasking, which means you're not doing anything worth a hoot.
That's a scary proposition, isn't it? Yeah, how about we can show it maybe when we're doing some Q&A afterwards, just so I can finish it. We'll do that. And so, like I mentioned, this RTMA issue is very much related to the quality that we see in gridded forecasts, where they're very much tied in the issues that we see. That being said, we're really excited about the evolution of this, silver standard that Gordy mentioned, and potential improvements that may come with that. And excuse me, this different type of aviation sensor that we could absolutely start incorporating into our gridded forecasts and projects like RTMA, because that's really it's going to be a hard nut to crack unless we get increased amounts of aviation observations. So these much cheaper networks that we can roll out much faster really have a lot of potential for improvements relatively rapidly. Once it's brought into our operations. I also wanted to mention the VIA project that's being studied with both the Weather Service, the FAA, working with MIT in trying to pull some objective visibility and potentially ceiling data from the webcams that we could potentially start bringing into projects like RTMA once that's in a digital format as well. That would be a really exciting advancement that we've been working with quite some time. And then did want to speak a little bit, because there was one question about, in particular, polar orbiting satellites in Alaska. Tom mentioned, yes, we're absolutely working with those and going through an evaluation with the cross-section project with GPSS. But just in the testing for GOES-R and GOES-S, we did a lot of development going back 5 or 6 years in utilizing the polar orbiting satellites as essentially a test bed for the new era of satellites. So there are some products that we use on a regular basis when it comes to flight category that are based off of not just the GOES-R satellite, but in a much higher resolution polar orbiting satellites that we're trying to find some way to pull into our gridded forecast operations. It's a little bit of a challenge because it's not really broken down by ceiling and visibility. It's really just a broad flight category piece of guidance. So it's a little bit trickier, but it's absolutely something that we've been using in our aviation forecast operations for the better part of 5 years now. And then also just wanted to briefly mention the challenge we have with the AAG experiment. The early verification and feedback that we've received on that is promising for these short-term VFR operations for focused on just kind of making these go, no-go decisions. So when we look at verification of, hit rate for IFR or VFR conditions, meaning, if it forecasted IFR, did it hit IFR, not necessarily trying to break down, say, 500 versus 800 foot ceilings, just breaking it down at a very simple level, the AAG has performed fairly well. The question then remains the quality of LAMP guidance in particular, especially in that 6-hour period, is very much tied to the use of the observation. And so how do we move forward with the rest of the 157 sites that most of them don't have an observation and likely will not have an observation anytime in the near future? So this would be a good area as far as, potential sites to offload or to start with this VWAS weather network. That would be a huge help with a project like AAG, to where, even though it's not a certified observation, we could provide a much higher quality piece of guidance when there would be a VWAS type sensor there than if there was, no sensor whatsoever. And I think that's my last slide. Yep.
And David, thank you very much. This is Matt. I'm going to stop sharing, and I've actually now given you permission to share. So rather than go through this whole, move stuff around, if you'll just go to that dashboard and click that the share icon, which is the rectangle with the up arrow on it, you can then share your screen and maybe show us the slides that you wanted to show us.
Sure.
And for the rest of the group, while David's doing that, for the rest of the group, I do this on purpose to try to keep us as simple and limited as possible. And yes, we see your screen, David. Thank you.
Okay, wonderful. Yeah, so these are the 3 areas I was wanting to point out. So the purples that you see here are ceilings less than 500 feet that you can see. So this is comparing the 0-hour analysis from that gridded LAMP forecast to the HER and to the RAP at the same time. You can see, the RAP especially kind of had more localized areas of the low IFR conditions. But because the background LAMP field did not have that in the forecast, you can see the pretty major, one of our scientists calls these tuna cans when we see this in the analysis, because especially you see them like in the Aleutian Islands, it will just be a huge circle that will appear as the observations come in. So, definitely put some limitations into utilizing a project like this, because it definitely, this area in particular is much larger than any area that we saw on, say, any of the satellite-based projects that we looked at for the same time frame. So this was likely just a isolated IFR observation within a river valley that was, associated with a sort of like river valley fog that was, once the model guidance brought this in, applied it to a much too broad of an area. And you see that to the west here, and then also just in some areas of Canada where you have, some similar issues of limited coverage.
Very good, David. Thank you. Dave Strand, over to you for Qs and or As.
Okay. We have a couple of questions that have come in. And as would be it, I always have them, here we go, I have them queued up and then I lose it. This is from Michael Split. How do you pull in Mesonet data?
Quite easily. So all of that comes into our AWIP system the same way, whether we're talking about a certified weather observation or, you know, any other observation from the non-certified world. We're pulling in everything from MesoWest, and so it's kind of a one-stop shop from an observational perspective. You know, quite frankly, when it comes to our forecast operations, we don't really separate certified versus non-certified. So we are using every observation from every platform that we could possibly get our hands on.
All right. And let's see, I'll skip that one here for the moment. Where can I get information on VWAS? That's from Donald Burkhoff.
I can take that one. So Don, I'll have a presentation in the next panel, and after that, in the end of that presentation, we'll have our contact information, so we'll be able to take any further questions offline on the VWAS and the development. So after the break, we'll go to that.
All righty, and one last one. I'll just read it. It looks like it was answered from, I'll probably butcher the name, I'm sorry, Christian
Amaral.
Amaral. How long does it take for, typically for an AWAS outage to be repaired? Is there a variation between time required in Alaska and CONUS? And Matthew Tucker answered back, it could be days or more in Alaska. And in the CONUS, depends on the sensor, but a major outage has a 4-hour callback depending on proximity to technicians. So I just read that for the benefit of the rest of the group there. But any more questions? That was the only ones that I had in the queue here. All right, that was great, David. Back over to you, Matt. David?
And I'm going to hand it off to Gordy, since this is his session. I believe this concludes panel number 1. Gordy, did you want to try to stimulate further discussion, or do you want to, what's your pleasure at this point?
No, I will just a closing comment on panel 1. So I guess what the intent here was, and we hope we hit the intent. We hope the intent here was to show aviation's changing. You know, I mean, if you look to where we're going with panel 3 and UAS, and to look at the issues that Alaska has historically, you know, dealt with, and you look at the risk, and you look at the criticality of Alaska. To me, Alaska is the test bed, and let's work to fix Alaska. Let's look to improve the weather modeling in Alaska. It's a win-win all the way around. The AAG product, that was our idea to try to fix the forecasting, you know, hole in Alaska, because the amount of forecasts is limited, and as David clearly pointed out, you know, they're struggling even with the 157 sites they have up there. A dozen or so, you know, may on the average be out of service or unreachable. So that really limits them and hampers their operation in the forecasting field. So we really hope that this proves the thought that we do need a different standard. We do need to use better technology, and we do need to kind of open this up to industry to kind of help us fill the void. So this is our attempt, and we're hopeful in panel 2 we'll show where we're going next, and then panel 3 will show what some of the research we're going to do, and then open the floor up to industry to kind of discuss what their thoughts are. So unless there are any other comments, Matt, are we taking 15 minutes here?
Well, so let's before we stampede out for break, let me just say that the way that we all thought that we would organize this session in order to try to keep some degree of sanity in it, was to do all of the Q&A through the chat window, which y'all have been doing. And thank you to the SMEs who are also on the call for answering those questions, even as they're coming up. That's great. Appreciate it, Matt Tucker, for answering Christian's questions so quickly. But at the risk of creating pandemonium, is there anybody who would want to unmute themselves and either, have as close as we can a conversation with the panel given this context? Or if not, then I think we'll take a break. And Matthias, I would look to you and say, is it 15? Is it 20? We're running about 15 minutes ahead of schedule, which frankly, I had forecast ahead of time that we were going to be running way behind schedule, and clearly I can't forecast worth a hoot. So in any event, how about if we just open up to the 120 or so people who are on and say, does anybody have any question that they would prefer to verbally ask at this point? And if so, identify yourself, try to point it at a person, and we'll see if we can make this work without creating pandemonium.
Hey, Matt, it's Rocky.
Hey, Rocky.
Hey, I want to follow up probably with Gordy on the question I had about, the VWAS versus AWAS. And, the answer was that the certitude of the system was the reason for the order of magnitude difference. And in my mind, certitude usually equated to things like, taking care of things like faulty temperature or pressure sensors, that, keeping bad information from getting into the system so you don't have the misleading, potentially hazardous information.
Right.
And the answer I got was, well, the VWAS should be even better. But then somebody else, I think, also said, but we're still going to have AWAS, and we're not planning on VWAS replacing AWAS. Well, geez, it sounds like if it really is better, wouldn't it be a good idea to, why have AWAS anymore?
Well, that's a great question and an excellent comment, and we're hopeful. Okay, I think it's kind of like anything in aviation. You got to kind of prove that it works, and prove that it can be effective, and it will, be able to have staying power. So in other words, will the system be reliable enough, for an IFR infrastructure? We are hopeful, and in fact, one of the test sites we're going to be working with in Alaska is the development of a new RNAV procedure in Alaska, and we're really hopeful that this will prove itself to be very effective. The side-by-side effectiveness, we think it's going to come in just great. One of the key things in approving a system like this is sighting and sensor sighting and proximity. And we have that down. I mean, Walter's team has that down. That's one of the big things that the FAA does very well when they certify it. They certify the sensors, and then they have the array, and they go out and they certify the location, and then they've got the communication capability, and oh yeah, there's a VHF frequency that has to be obtained. So there's a lot of things here that, VWAS using the different telecommunications capability, which I'll show you in the VWAS, what we're planning to do, kind of leapfrogs that a little bit. But I really want to make it clear that AWAS and ASOS, they're pretty tried and true. Alaska being very unique in its geography and its climate poses a lot of challenges for equipment. And if Walter was on, I'm sure he would agree that he has weather camera issues in Alaska. So it's just a matter of can you prove a system to be good enough, and if you bring that system to the lower 48, you might find that it is better and it is cheaper and it's easier to maintain. So I mean, we're hopeful that this will all play out. We truly believe it will. But we've got to put our cards on the table, and we've got to do that through data. So there will be a data analysis on this, and so yeah, that's a good question though.
All right, this is Dave Strand. We did get one more question here on what are the elements of actual work that drive up the cost of AWAS certification versus VWAS so substantially?
Well, I can't speak to that. You know why the cost is so high. I can tell you that the weather sensors that we're using are Vizsla weather sensors on the VWAS. That's what we're starting with. But you know, the goal is to be able to write a standard to that and kind of open that up. And we're hopeful that the industry will respond, and the industry will be able to, you know, provide sensors technology for cheaper in cost, and maybe even VWAS dollar amount will come down even further. I mean, open it up to the free market. You know, right now the AWAS standard is very rigid, and so you know, through many attempts we've tried to get wider access to weather information, Mesonet data, for example, MADIS data. A lot of that lacks information. A lot of that lacks, you know, controls. And the Weather Service does a great job of being able to weed out the bad sensors. You know, and when they put that in, there's that solution into RTMA, they do just that. We're hopeful to kind of raise that bar and get a silver standard here that's high enough, it's good enough for, you know, these remote operations that fills the void. But to answer the specific question, why is it so high? I can't 100% answer that.
Gordy, I could shed a little bit of light into that, because I had a similar question when it came to our MAWS system that I worked with Artex not too long ago, which is very, very similar to what Walter's doing with the VWAS network, and you know, in many ways using the same sensors that we see on the AWAS on a much cheaper network. It's really everything else that goes in the construction footprint of an AWAS that goes into the cost that that we're not necessarily putting in, say, our MAWS system, and Walter isn't necessarily on his VWAS system. You know, so it's you know, as far as, you know, maybe I think one example I was given would have been like how deep we're putting the footings for something like the concrete pylon for the tripod, you know, that are really going into like the construction costs of putting these sensors in, where the sensor itself might be the same, but the actual cost to install it are substantially different.
Right, and the other thing is too is the weather camera network is already established, and many of the weather cameras are at locations where there's AWAS. Many of them aren't, but you've already got some connectivity there. So there's little synergy that can be had by adding VWAS to an existing infrastructure that's already there. So there's savings.
For the folks who were not following, the speaker in between two Gordys was David Kochevar from the Alaska Aviation Weather Unit.